All right, good morning. This is your Stat Sensei, Mr. Spensei, and this is exit ticket for Want Some Candy, which we've already worked with. So, a candy machine is supposed to fill bags of candy with an average of 19.25 ounces of candy. A random sample of 32 bags out of a batch of 5,000 had an average weight of 19.22 ounces, and a sample standard deviation, I should have said sample standard deviation, of zero point 0.1 ounces. Oops. Create a 95% confidence interval for the actual amount of candy in the bag. All right, so the very first thing we need to do is we need to write our formula. Our formula, X bar plus or minus T star S divided by square root of N. X bar in this case was 19.22 ounces. N, they told us we had 32. Standard deviation, they said, was 0.1. Degrees of freedom. Freedom is going to be 32 minus 1 or just 31. Calculate T star. Remember, it's going to have to go to inverse T. It's going to ask us for the area. That's going to be 1 minus 0.95 divided by 2 because it asks for a 95% interval. And then it's going to ask us for the degrees of freedom, which is the 31 that we just wrote down. So let's go ahead and do that. So second vars, inverse T, parenthesis, 1 minus 0.95, close parenthesis, divided by 2, degrees of freedom, 32 minus 1, or just a 31. Well, we get a T star of 2.0395, make it positive. 2.0395. That's T star. So we can go ahead and plug that in. And we're going to have our X bar, 19.22, plus or minus 2.0395 times S. S is 0.1 over the square root of 32. Make sure you're using your sample size there, not degrees of freedom. We're drawing a picture. Hypothesis tests are centered on the mean. However, confidence intervals are centered on X bar. So this is centered on X bar, and our X bar is 19.22. And we want this area right here to be 0.95, which means this area right here is 0.025, and this area right here is 0.025, and this is my lower bound, and that's my upper bound. All right, inference procedure. Well, we only had one sample, so we're going to tell them that. One sample. The distribution is the T. We're running an interval. For what? For means. All right, we can go ahead and run this thing now. Stat test. Drop down to number 8, T interval, 19.22. Standard deviation of the sample of 0.1. Sample size of 32. Confidence level of 95%. And we get an interval of 19.184 to 19.256. So here's my lower, and there's my upper. All right. So what are we? We are 95% confident that the true population mean candy weight lies within the interval 19.184 to 19.256. All right. We didn't have to do the, on this one, we did not have to do the conditions because we did that on a prior work. The meaning, in repeated sampling, we expect this method to capture. In other words, how good is it? Well, if we do it over and over again, we expect our method to capture the true population mean candy weight. How often? 95% of the time. All right. That's it. Appreciate you watching and sure hope to see you on the next one. Thank you.